As my dear students of 10th standard, I welcome you to move furthermore in the types of chemical reaction. Already we are started. Still some more part to complete the types of chemical reaction. So in the introduction part already you have learned that is chemistry means chemical reactions, and in chemical reaction there are reactants and products. Reactants are nothing but the substances which undergo chemical changes in the reaction, are the substances shown in the left hand side of the arrow mark, and the new substances formed in the reactions are called product. This is always in the right hand side of the arrow mark. What is the meaning of that arrow mark? That arrow mark indicates the direction of the reaction, and usually we used to write the equation in the form of word equation. Then we have to convert it into molecular formula, and we have to check whether the equation is balanced or not. So what is called balancing? According to the law of conservation of mass, either side of the arrow mark, that means the atoms of the reactants and the atoms of the products should be in equal number. Mass should be equal in number both the side. Then only the equation is balanced. Otherwise it is called a skeletal equation. Then already we have learned about the types of chemical reaction. And the types of chemical reaction based on the manner in which the atoms are arranged, combination reaction, and next decomposition reaction. The combination reaction is nothing but two or more reactants combined to form a single compound, and decomposition is opposite to the combination reaction, that is a single compound split into smaller fragments, simpler fragments, that is called a decomposition reaction. Then next see a single displacement. So displacement reaction means the reactant, an element, replace an element in the compound of the reactant. The compound of the reactant. Then next to see that you have learned about the differences between combination reaction or decomposition reaction. Then the double displacement reaction, when two compounds are react, the ions are rearranged, interchange themselves to give a new product. This is also called metathesis reaction, and there are examples are there, and in these two types are there: precipitation reaction, a reaction which produce precipitate, that is called as precipitation reaction. And the next one is the neutralization reaction. Normally when an acid react with the base, salt and water are formed. This is called a neutralization reaction because an acid is neutralized by a base. Then combustion reaction. In the combustion reaction, majorly heat energy is main source, and here the rapid combination of reactant with oxygen take place. The rapid combination of oxygen with the reactant. So oxides and heat energy will be evolved. Examples are there when hydrocarbons burn in presence of oxygen, normally carbon dioxide, water, and enormous amount of heat energy will be evolved. Then digestion of food, rusting of iron. And see, all the combustion reactions are oxidation because the combustion take place only in presence of oxygen. Addition of oxygen is oxidation. But all the oxidation reaction will not produce a flame in the form of heat energy. So those reaction which produce flame, those only called a combustion burning process. Next, see classification based on the reactions of the based on the direction of the reaction. You know that innumerable changes occur every day around us are all the permanent. For example, liquid water freezes into ice, then ice into liquid. So here the freezing process is reversed. So it is not a permanent change, it is a physical change. So physical changes can be easily reversed, but chemical changes cannot be easily reversed. For example, consider the burning of wood. So the carbon compound present in the wood are burnt into carbon dioxide gas and water. Can we get back the wood immediately from the carbon dioxide and water? It is not possible. It cannot. So it is not a temporary change, it is a permanent change. In most of the cases, we cannot get the reactant again. But some of the chemical reaction can be reversed. For example, see the recharging of mobile phone. So in this lithium ion battery is there. So the inactive materials are going to be activated when we going to charge with the plug point. So when we get charge from the battery, that is called discharge. That is called discharge. On recharging the mobile, the reactions are reversed. Chemical reaction may be reversed only under suitable condition. Hence, they are grouped into two categories such as reversible and irreversible reaction. Reversible reaction means that reactants can be obtained again. The reactants can be obtained again. So in the reversible reaction, we cannot get back the reactant. So first reversible reaction. A reversible reaction is a reaction that can be reversed. That means reaction take place in both the direction, in the forward direction, also backward direction. That's why you see in the arrow mark, both the side arrow marks are given. That means see the compound AB decomposed to give A plus B. The compound AB decomposed split into A and B. Again, when you supply the suitable condition, the product A and B again combine to give the reactant AB. To give the reactant AB. That's why you see the arrow mark is given both the way direction. See the AB compound into A plus B is forward reaction. Then A and B gives AB, that is backward reaction. So double arrow mark is given, and reversible reaction usually represented in this form of arrow mark. So here the compound AB undergo decomposition to form the product A and B. It is called forward reaction. As soon as the products are formed, they combine together to form AB. It is called backward reaction. So the reaction take place in both the direction. Do you think then that no products are formed in the aforesaid reaction? If you think so, you are wrong, because even though the reaction take place in both the direction, at the initial stage, the rate, the speed of the reaction are not equal. But after some time, the decomposition reaction take place, there will be an equilibrium between reactant and product. There will be an equilibrium between reactant and product. For example, consider the decomposition of phosphorus pentachloride PCl5, phosphorus P pentachloride Cl5, which is in gaseous state. On decomposition, phosphorus trichloride and chlorine gases are formed. The forward reaction is a decomposition of phosphorus pentachloride, and backward reaction is combination of phosphorus trichloride. So in the beginning of the decomposition reaction, the decomposition reaction proceeds faster. See, phosphorus pentachloride decompose at faster rate to give the product of phosphorus trichloride and chlorine. After some time, the speed of both the reaction become equal. So phosphorus pentachloride cannot be completely converted into the product as the reaction is reversed. So it is reversible reaction. So normally in the reversible reaction, only a portion of reactant decomposed to give the product. Similarly, a portion of the product combined to give the reactant. So always there will be an equilibrium in the reversible reaction. So amount of PCl5 is more that of PCl3 and Cl2. So when we go into measure actually, the actual measurement it will give PCl5 is more compared to the product of phosphorus pentachloride and chlorine. But even though we consider there will be an equilibrium between the product and reactant in this type of reversible reaction. And see, if hydrogen peroxide methanol poured on a wound, it decomposes into water and oxygen. The gaseous oxygen bubbles away as it's formed and thus prevent the formation of hydrogen peroxide. And more amount of products can be obtained in a reversible reaction by the periodical removal of one of the product of the periodical addition of the reactant. So here say in the decomposition of hydrogen peroxide is decomposed into water and oxygen, and further it combined to give water and oxygen combined to give hydrogen peroxide. So if you are going to remove the periodical removal of the product, what will happen? See, more amount of product can be obtained in the reversible reaction. When you are going to remove the product, any product, suppose the products are not removed, only these reaction take place under suitable condition. If you don't remove the product, it will going to attain equilibrium at one stage. Then irreversible reaction. The reaction that cannot be reversed is called irreversible. So reversible reaction means that can be reversed. That means reactant give product, then product combined to give reactant. The irreversible reaction, the reactant combined to give the product, but product will not recombine to give the reactant once again. That is called the irreversible reaction. So it is a unit direction, only one direction. So arrow are given only one direction, forward direction. So they take place only in forward direction. Consider the combustion. So normally all the combustion reactions are irreversible reactions. Irreversible reaction. When any hydrocarbon, firewood, any fuel burn in presence of oxygen, it going to carbon dioxide, water vapor, and heat energy will be obtained. This cannot be recombined to give the reactant once again. So these type of reactions are irreversible reactions. And here one example is given. See, coal, which is a carbon solid, and when combined with the supporter of combustion oxygen, gaseous oxygen, carbon dioxide gas will be formed and enormous amount of heat will be evolved. So in this solid coal burns oxygen and gets converted to carbon dioxide gas and water. As the product is a gas, as soon as it forms, it escapes out of the reaction from the container. So carbon dioxide tries to escape. So it is extremely hard to decompose a gas into solid. It is not easy to again bring solid from the carbon dioxide gas. So the backward reaction is not possible in this type of reaction. So it is called a irreversible reaction. And see table 10.2 provides the main differences between reversible and irreversible reaction. For example, see, in the reversible reaction, it can be reversed under only suitable condition. The condition is very, very essential, and irreversible, it cannot be reversed. Product cannot be recombined to give the reactant. And here both forward and backward reactions are take place simultaneously at the same time. But it is any direction. The direction only forward direction. It produces only forward direction. And reversible reaction, the reaction products are going to attain equilibrium at one stage. But here there will be no equilibrium, and reactants cannot be converted completely into products. So in the reversible reaction, only a portion of the reactant decomposed to give the product. So complete decomposition, complete conversion of reactant to product will not be obtained in the reversible reaction. But here in the irreversible reaction, the reactant can be completely converted into product. Then reversible reactions are normally take place in slow rate, but irreversible reactions are fast reactions, rapidly take place. So you will learn more about this reaction in your higher standards. Then rate of chemical reaction. You are seeing, so far we discussed various types of reaction and the nature of reactant product. Let us consider the following reaction: rusting of iron, digestion of food, burning of petrol, weathering of rock. So how fast these reactions are take place? Rank them from the slowest to fastest. How will you determine which is the fastest and which is the slowest reaction? One of the way to find out how fast a reaction is as follows. Measure the amount of reactant or product before and after a specific period of time. So here we have to measurement that measuring the product and reactant after a specified interval of time. For example, let us assume that 100 gram of substance A undergo reaction, and after an hour 50 gram of A is left. So A is the reactant, it converted into product. So it turned to 100 gram turned to 50 gram. So in another instance, 100 gram of substance C undergo a reaction, and after an hour 20 gram of C is left. Can you say which is the fastest reaction? In the first reaction, 50 gram of the reactant A converted into product, where in the second reaction 80 gram of reactant is converted to product. So the second reaction is faster compared to the first reaction. So the measurement is called reaction rate. So what is called a reaction rate? The reaction rate is the change in the amount or concentration of any one of the reactant or product per unit time. And here a simple illustration is given. A is the reactant and it decomposed to give the product B. So there is a formula to calculate the rate of a reaction. Rate of a reaction is equal to minus dA by dt, that is equal to plus dB by dt. What is the meaning of that negative sign? That negative sign indicate the decrease of concentration of the A in particular interval of time. At the same time, the plus sign indicate the increase of concentration of product B in the specified time. So initially that the rate of the reaction is going to be faster. That means that reactant decomposed to give the product fastly. That's why you see the decomposition takes place fastly. The minus sign is given. And after some time what take place? See, the reactant going to increase in their volume. So that's why the plus sign is given. The concentration of the product will be increased after certain interval of time. So note that that box represent the concentration, D represent the infinitesimal changes in concentration. So the change of concentration, so the D indicate in the bracket, the D indicate the change of concentration in particular interval of time. So why is the reaction rate is important? Faster the reaction, more will be the amount of product in specified time. So the rate of the reaction is important for a chemist for designing the process to get a good yield of a product. Rate of reaction is also important for a food processor who hopes to slow down the reaction that cause food to spoil. Normally, this type of rate of reactions are very important to synthesize the reactant into product, because in a particular interval of time, the particular rate of reaction, that reactant decomposes to give the product. So the rate of reaction is very important. Also mainly in the food processing institute and the food processing industry, this type of rate of reaction is important, because they have to slow down the reaction in some cases. They have to increase the rate of reaction in some processing to control the spoilage of food. Otherwise the food will be spoiled. The food will be spoiled. So the processing unit, this type of rate of reaction is considered very important. So my dear students, the factors influence the rate of reaction we will discuss later. So far we have discussed about there is the classification based on the direction of the reaction. So there are physical changes. The physical changes are temporary changes. For example, water into ice, ice into water, like that. But chemical changes are permanent. Only under suitable condition, the chemical reactions can be reversed. Based on that, we are studying two category of reaction: reversible, irreversible. Reversible means the reactant decomposed to give the product again recombined to give the reactant. That means the reaction can be reversed only under following uh, some specified conditions. Then irreversible reaction, the reactant decomposed to give the product, a reactant combined to form the product, but product will not recombine to give the reactant. So this is only forward type of reaction. Normally the combustion reactions are irreversible reactions, and you have to learn about the difference between reversible and irreversible reaction. And the rate of chemical reaction is important, and rusting of iron, digestion of food, all these are oxidation reaction, combustion reaction. Burning of petrol, it is a combustion reaction. And see, so the rate of reaction is very important. The rate of reaction is very important. What is called rate of reaction? The change in amount of concentration of any one of the reactant or product per unit time. There is a formula, and the negative sign indicate the decrease of concentration. The positive sign indicate the increase of concentration. So normally the rate of the reaction is important in the factories and industries to designing the process to get good yield of the product, and also in the food processor unit this rate of reaction is very important. So my dear boys, we will see the next topic in the next class, and already we conducted two tests, that is on atoms and molecule and periodic classification. Next test, ninth unit solution. Next test, ninth unit solution. You prepare all the objective in the exercise textbook evaluation, and also in the inside the book. You prepare thoroughly, and only 25 questions are given. So you have to do it fastly, and don't give reasons, and you have to get ready with your device, and see boys, and you have to submit only uh, uh, one trial, first trial. I am going to take your first trial mark. So many students are submitting so many trials, second, third, fourth trial. Those trial will not be considered. Only your first trial mark will be considered. Those marks only taken and registered in the mark list. You are going on attempting again and again and again. First one by getting 4 mark, then 10 mark, then 15 mark, then 20 mark. Finally, after 6th and 7th trial, getting 24, 25 mark. Those type of trial and error method is not given here. This is not a trial and error method of writing test. So you revise thoroughly. You apply this trial and error method and the learning process. You many times revise again and again and again. You revise and write the test sincerely, truthfully, and your marks will be considered and taken. Only the first trial mark will be entered in the register. All the other test marks will be omitted, will not be considered. So do it sincerely, and you prepare well and write the test in the given specified time. Uh, and also you have to revise these types of chemical reaction and prepare well. Thank you. God bless you.